Department of Environmental Science, Sevadal Mahila Mahavidyalaya and Research Academy, Nagpur. The technical assistant, our beloved Miss Shreya Indurkar, a research scholar at the host institution, and the wonderful participants who have enrolled themselves for this course. I, Dr. Vaishali Meshram, Assistant Professor of English at Dr. M.K. Umarthe College, Nagpur, welcome you all to the inaugural session of the 2 weeks refresher course in Environmental Science on the theme Understanding the Various Aspects of Prevention of Pollution to Attain the Goals of Sustainability, commencing from 17th of July to 29th July 2023. Ladies and gentlemen, Sevadal Mahila Mahavidyalaya Nagpur, known for its commitment to empowering women through education, takes immense pride in hosting this refresher course. The institution has always been at the forefront of nurturing young minds and instilling a deep sense of environmental responsibility within the students. With this course, the institution aims to further strengthen the commitment to environmental education and foster a generation of change makers. As it is rightly said,
मैम माइक में बोलो।
sorry for the technical glitch. Vidya, as it is rightly said, Vidya prashaste loke, Vidya sarvatra gaurava, Vidya labhate sarvam, Vidwan sarvatra pujyate. Ladies and gentlemen, we have a versatile, illustrious, and a multifaceted personality amongst us today. It is indeed an honor and great privilege to welcome and introduce the chairperson of the inaugural session, Honorable Dr. Praveen Charde, sir, Principal Sevadal Mahila Mahavidyalaya and Research Academy, Nagpur. He is a great academician and an outstanding administrator with almost 26 years of teaching and administrative experience. Under the inspiring leadership of this dynamic principal, the college has witnessed an unprecedented growth and development in all aspects and received A grade in the third cycle of re-accreditation by NAC. He has been instrumental in getting grants worth more than 10 crores from various funding agencies, including UGC for minor, major, and two innovative projects, BO courses, community college, hostel grants, and other developmental grants. He is a recognized PhD supervisor for zoology and environmental science subjects. 12 students have been awarded PhD degree in zoology, while 6 students have been awarded PhD degree in environmental science. Many students are pursuing research under his able supervision. He has published more than 100 research papers in the national and international journals of repute and also has a patent to his credit. He has traveled far and wide to the countries like Israel, Thailand, Mauritius, Netherlands, Dubai, Singapore, and Sri Lanka for conference participation and paper presentations. Besides, being a member of several committees, including the chairman of Board of Studies of Environmental Science, as well as Academic Council of the University, he is also the member of Planning Advisory Board for Gorewada National Zoo project, started at Nagpur, and a technical advisor to Raj Bhavan for developing Biodiversity Park. Sir, we are extremely happy to have you here with us today. We accord an affable welcome to you. Ladies and gentlemen, we have the second notable, a sagacious scholar, and an exceptional administrator in our midst today. I feel extremely proud to welcome and introduce the guest of honor of today's program, Honorable Dr. Chandrasekhar Dethe sir, to the august audience. Dr. Dethe sir is the director of UGC HRDC, RTM Nagpur University, Nagpur. Sir has served the renowned institutions of Shegaon and Nagpur in numerous capacities and has total experience of around 32 years in the field of teaching and administration. He has done MTech and PhD. He is a recognized PhD supervisor at RTM Nagpur University, Nagpur, Sant Gadge Baba Amravati University, Amravati, Dr. Baba Sahib Ambedkar Marathwada University, Aurangabad, and Gondwana University, Gadchiroli. 14 students have been awarded PhD degree, while 5 are still pursuing research under his able guidance. He has published 88 research papers in the journals of repute and also published 45 research papers in the conference proceedings. He is a reviewer of the national and international journals. He has received several grants under various schemes of AICTE New Delhi. Sir has authored a book on an intelligent WLAN system, performance evaluation in multipath feeding environment. He has also published numerous chapters in books. He has one patent to his credit and has published three so far. He is a recipient of National Merit Scholarship. He is the ex-member of Board of Studies in Electronics in RTMNU Nagpur and BCUD Nagpur. He has been the organizing chairman of several national conferences, STTPS, and workshops. He was nominated for Brands Academy Education Award and Vidya Ratan Award by the Economic for Health and Educational Growth. Sir, we are indeed elated to have you here with us today. We accord an affable welcome to you, sir. Ladies
Thank you.
and gentlemen, we have a boisterous resource person for the first session and an academician extraordinaire. Honorable Dr. Pawan Labshetwar, sir, Chief Scientist and Head, Water Technology Management, NIRI, Nagpur, in our midst today. We are indeed happy to have you here with us today, sir. We welcome you. Ladies and gentlemen, we have an exuberant and dynamic course coordinator, Dr. Praveen Meshram, Professor and Head, Department of Environmental Science, Sevadal Mahila Mahavidyalaya and Research Academy, Nagpur, amongst us today. He is a man of action, extremely proactive, agile, and so meticulous in his work. It is commendable that he is handling the RC single handedly. I congratulate him on his praiseworthy achievement. I welcome you, sir. Without much ado, I now request Dr. Praveen Meshram, sir, to present introductory remark on this momentous event. Over to you, sir.
Thank you, madam. Let me give the introductory speech regarding the today's theme of this refresher course in environmental science. So once again, respected all the dignitaries, the chairperson of the today's inaugural session of this online refresher course in environmental science, Honorable Dr. P.N. Charade sir, Principal, Sevadal Mahila Mahavidyalaya and Research Academy, the chief guest and the resource person, the first session, my friend Dr. Pawan Labshetwar sir, who is working as the chief scientist and head, Water Technology and the Management Division, NIRI Nagpur. Today's guest of honor, Dr. Dethe sir, who is working as a director of UGC Grant Commission and Human Resource Development Center affiliated to our Rashtrasanta Tugdoji Maharaj, Nagpur University, Nagpur. Dr. Priti Dharmik, assistant professor from the same center. My younger sister, Dr. Vaishali Meshram, co-coordinator of this refresher course, working as a lecturer, working as assistant professor in English department of SK Umathe College. Other invitees and the galaxy of the intellectual participants, a very pleasant morning to all of you. I, as a course coordinator, take this opportunity to welcome you all to this refresher course in environmental science organized by UGC HRDC in association with Sevadal Mahila Mahavidyalaya Research Academy, Nagpur. The theme of this refresher course is understanding the various aspects of the pollution prevention to attain the goal of the sustainability. I am highly delighted to express my appreciation to the University Grand Commission and the HRDC Center of our Rashtra Sant Tukadoji Maharaj Nagpur University, Nagpur, for their vision and dedication in organizing this refresher course and for shouldering the responsibility to me as a course coordinator. Friends, being a teacher, it is our prime responsibility to nurture the young minds and make them aware of all the burning issues pertaining to environmental science and the objectives of the sustainable development. It is now universally accepted that any future developmental activities have to be viewed in the light of ultimate environmental impact. A tremendous increase in industrial activities and the release of the deadly dangerous waste into the environment have been the considerable concern in the recent years from the point of view of environmental pollution. At present, the numerous issues like quality of environment, ecological imbalance, depletion of the protective ozone umbrella, disruption of the Earth's natural ecosystem, greenhouse effect and the global warming, acid rains, loss of biodiversity, climate change, carbon sequestration, carbon credits, environmental protection, and sustainable development have been raised. Today, Mother Nature has been warning us repeatedly as our fellow beings are suffering from deadly diseases due to polluted air, water, and adulterated food. No doubt, man is now awakened towards the environmental degradation, and the public interest concerning the quality of environment has reached the emotional peaks. But my dear participant, can this tempo be sustained for the long time? Are the civilized country willing to slow down the pace of rapid industrialization and the urbanization? With this background, and in order to find out the sustainable solution to all the above queries, this refresher course in environmental science has been organized and designed. In fact, the main objective of this refresher course is to improve the teaching skills and update the knowledge of every participant. With this basic motto, experienced teachers and the renowned experts in the concerned subject areas have been invited. Mostly all these resource persons which are invited, they are all from National Environmental Engineering Research Institution, Maharashtra Pollution Control Board, Ministry of Environment, Forest and Wildlife, Maharashtra Remote Sensing Application Center, Department of Forest and Wildlife, and reputed professors of environmental science in various universities of all over the Maharashtra. My dear participant, I'm sure that you will find all the session will be highly informative and you will really enjoy this entire refresher course of 12 days. The exchange of the ideas and experience will definitely help you to widen your horizon and develop the innovative approach in teaching as well as research. The topics during this refresh course will cover a wide spectrum of environmental science ranging from theoretical aspect to the practical applications. Our esteemed scientist and the professor will focus on the topics like climate change, mitigation and adaptation strategies, industrial pollution and the treatment options, environmental policy and the governance, ecological restoration and the conservation biology, environmental impact assessment, pollution control technologies, basic concept of the green building, solid and hazardous waste management, green chemistry, and environmental legislation. I hope that together we can create a community of environmentally alert educators. We can inspire next generation. I would like to request all the teacher participants to actively participate. Go on sharing your ideas with experts and contribute to this learning experience. At last, I'm confident that this refresher course will enrich your understanding of the environmental science and providing with the tools to create the sustainable future. We all will be very happy to welcome your suggestions and the feedback from time to time, which will be helpful in organizing such type of refresher courses in future also. Lastly, I would like to congratulate all my entire team, all my members of the teaching staff and the research scholars of my department for their efforts in making this refresher course a great success. So, my dear participant, let us begin the journey of the knowledge and the collaboration with the enthusiastic great speakers, and wish every participants a productive and fruitful refresher course. Thank you all for being the part of the significant event. Thank you, madam. Over to Dr. Vaishali, madam.
Thank you so much, sir. May I now invite Honorable Dr. Chandrasekhar Dethe, sir, Director, UGC HRDC, RTMNU Nagpur, to share a few words of wisdom with us on this occasion. Dr. Dethe, sir, over to you.
Thank you, Mishra Madam. I hope I'm audible.
Yes, sir, you are audible.
Yeah. Good morning to all. President of today's inaugural program, Professor P.N. Charde, Principal Sevadal Mahila Mahavidyalaya Nagpur, Chief Guest Dr. Lakshitwar, Course Coordinator Dr. Praveen Meshram, and dear all participants present over here. Let me first of all congratulate Dr. Charde sir for taking his college to newer heights every time he faces the NAC and other visiting committees. I hope this college is going to be a very vibrant college and is going to contribute to a great extent to our learning society. Friends, our HRDC center today we are inaugurating another 2 refresher courses and 1 pre-PhD coursework. Friends, our HRDC center is quite vibrant because we have one more program which is very important on IKS, which is going to start from 31st July this month. IKS is Indian Knowledge System, and I'm happy to share that our HRDC center is one of the 6 centers all over the country which has been chosen for this particular course. Friends, today we are at a very right time that we are inaugurating this interdisciplinary refresher course on environmental science. This is quite a a concerned topic for every one of us. I hope that the constituents of this particular group, the participants are from different disciplines as such, not only from environmental science background, but they are also from other disciplines as well. Since this is interdisciplinary course, refresher course, so Dr. Praveen Charde sir has given quite a exhaustive background about the environmental science and its need today. We already are witnessing impacts of badly handling the nature because अभी हमने ये भी देखा है कि recent floods in Gujarat, Delhi, or not only in our country but as well in other countries of the globe. जैसे चाइना में देखा है और पाकिस्तान में देखा है, अमेरिका में हरिकेन्स देखे हैं, यूरोप का कभी इतना टेम्परेचर नहीं राइज हुआ था, वो भी अभी हो रहा है. So a lot of climate changes are happening at the backdrop, and the simple reason for this is that we are not honoring the nature as such. Its natural habitat we are disturbing every now and then. We are building tunnels, roads, dams, and so many other things, as well. Greenfield ice is creating a trouble, and that leads to the global warming. And it's also said that if that happens, then overall temperature of this globe is going to rise by say 1 to 2.5 degrees also, and that is really is going to be a great trouble for the overall humanity as such. So हम सबकी ये जिम्मेदारी है कि हम हमारे एनवायरनमेंट को ऑनर करें. Last time you might have witnessed already that कि जब कोविड का टाइम था तो then we used to get a very clean air, और काफी वीडियोस व्हाट्सएप पे भी आए थे कि नदियों में मछलियां और बाकी सब चीजें और पोल्यूशन नदियों का काफी हद तक कम हो गया था. But then again, we have not realized its importance, and we are back to the same square again. So as a teaching fraternity, it's very important for all of us to realize this threat for the overall humanity as such, क्योंकि हमारे ह्यूमन मनकाइंड के लिए ही ये बहुत बड़ी थ्रेट है अगर हमने अभी इसके ऊपर सीख नहीं ली तो, क्योंकि आने वाली जनरेशन्स के लिए बहुत सारे प्रॉब्लम्स हो गए, बिकॉज देयर इज हैपनिंग अ लॉट ऑफ पोल्यूशन ऑन द सरफेस वाटर. एयर पोल्यूशन इज देयर, जहाँ पे हमको सांस लेने के लिए भी तकलीफ हो रही है. ऐसे कई सिटीज है, एंड इंडिया इज वर्स्ट हिट कंट्री फॉर दैट पर्टिकुलर थिंग. जैसे हम दिल्ली देखते हैं और बाकी भी जगह पे देखते हैं कि हमारा एयर क्वालिटी का ग्रेड है तो बहुत लो हो चुका है. सो ये सब चीजें हमने अभी समझ लेना चाहिए, एंड देन एज अ टीचिंग फैटर्निटी इट इज अवर मोरल ड्यूटी टू टेक इट टू दी स्टूडेंट्स एज सच, क्योंकि हम जब तक स्टूडेंट्स को सेंसिटाइज नहीं करेंगे तब तक मेरे ख्याल से हमने कोर्स करने का कोई जस्टिफिकेशन नहीं मिलेगा. So it's very important for all of us to realize the importance of this particular topic. Or I am sure that Dr. Praveen Charde is quite a dynamic person, and he will justify the presence of participants in this particular course, and will really have the great value addition to the knowledge of our participants on this particular front of environmental science. Friends, he has committed that he is going to have the great pool of resource persons, renowned resource persons from various fields of environmental science, and will really enlighten the participants who are participating in this particular course. But also at the same time, I would request all the participants to be attentive, be regular. Let us not skip the sessions. Otherwise also probably Dr. Praveen Meshram sir would be having the attendance of the participants as well. तो ये हमने seriously लेने की जरूरत है, और ये सब चीजें समझने के लिए your active participation in the sessions is quite important. हम खाली ऐसे क्लास में बैठ के सुनने से हमको कुछ गेन नहीं होगा. So I would encourage all the participants to really get through all the sessions, और active participation उसमें करिए, आप queries raise करिए, so that when you go back to your students and students ask you some some things about the environmental science, at least even though we are not from that discipline, but we should be in position to answer their queries prima facie kind of thing. तो ये सब चीजों की मेरे ख्याल से हम एज अ पार्टिसिपेंट्स समझने की जरूरत है, एंड इट इज अ ग्रेट कंसर्न फॉर आवर कंट्री, क्योंकि यूनिवर्सिटी ग्रांट्स कमीशन, फॉर दैट मैटर मिनिस्ट्री ऑफ एजुकेशन, इज स्पेंडिंग लॉट ऑफ मनी फॉर training our faculty members, and faculty members का ही अभी moral responsibility है कि it should not be looked upon only from point of view of our caste certificate, but as well as a responsible I mean as a responsible person in the society. हम society को इस चीज के बारे में lead भी करें. हम सोसाइटी को सेंसिटाइज भी करें, नॉट ओनली स्टूडेंट्स, लेट अस नॉट लिमिट आवरसेल्व्स टू आवर स्टूडेंट्स, बट एज वेल हम जो यहाँ पे भी रहते हैं, आजू बाजू में रहते हैं, उनको भी एनवायरनमेंट के बारे में अवेयर करें। ये हमारी जिम्मेवारी बनती है। बहुत बार देखा हमारे आमने सामने भी बहुत गार्बेज रहता है, बट देन नोबडी टेक कॉग्निजेंस ऑफ दैट। तो देर इज अ सिस्टम, वो सिस्टम को जैसे कारपोरेशन है, वो ऑनलाइन उनके एप्स है, मेनी ऑफ अस डोंट नो दैट कि एप्स में आप कुछ कंप्लेंट डाले तो उसका रिजोल्यूशन हमको मिलता है। तो ये भी सब चीजें हमको समझने की जरूरत है। और एज अ एज एन इंडिविजुअल यू आल्सो कैन कंट्रीब्यूट। तो हमने तो तय कर लिया है कि एज फार एज पॉसिबल मैं कहीं भी जाऊँ तो मैं साइकिल लेके जाता हूँ। सो लेट अस नॉट पोल्यूट अवर एयर एज सच, जहाँ तक पॉसिबल है। ऐसी बहुत सारी चीजें हैं जो हम आई मीन अवॉइड यूज ऑफ प्लास्टिक एंड ऑल, हम एज एन इंडिविजुअल कर सकते हैं, एंड दैट सेट्स एन एग्जांपल इन एंड अराउंड अस। तो ये भी सब चीजें हमको समझने की जरूरत है मेरे ख्याल से। और आई होप दैट it is going to be a great experience for all the participants। और मैं सेवादल महिला महाविद्यालय को कंग्रेचुलेट करूंगा कि वो होस्ट कर रहे हैं ये प्रोग्राम को, विच इज ऑफ क्वाइट ग्रेट इम्पोर्टेंस फॉर द ह्यूमन मैनकाइंड एज सच। मुझे तो खाली 5 ही मिनट दिए थे मैडम ने एज अ शेड्यूल, बट थोड़ा सा ज्यादा मैं समय लिया, तो आई एम रियली सॉरी फॉर दैट। बट देन I thought that it's my duty to sensitize my participants on this occasion. I extend my sincere thanks to the organizers for giving me an opportunity to share my views on this particular topic with the participants. I once again extend my sincere thanks, and thanks for the patience listening. Thank you so much.
Thank you so much, sir. Thank you so much for the enlightening and the thought-provoking speech, sir. It was really wonderful. Ladies and gentlemen, the chairperson of the inaugural function, Honorable Dr. Praveen Chade, sir, had to leave the meeting due to some inevitable reason, but he has sent his best wishes for the success of RC. Thank you so much, sir. Let's move on. I now request Dr. Sanjay Pal, sir, Associate Professor, Department of Environmental Science, Sevadal Mahila Mahavidyalaya and Research Academy, Nagpur, to propose the formal vote of thanks. Dr. Sanjay Pal, over to you.
Good morning to one and all. Honorable Dete sir, Lab Chettiwar sir, Honorable Cherde sir, and all the resource persons, invitees, and participants. I would like to take this opportunity to propose a formal vote of thanks. First of all, my sincere thanks to today's chief guest, Dr. Pavan Lab Chettiwar sir, renowned scientist and head, Water Technology and Management Division, NEERI Nagpur, for accepting our invitation in spite of hectic schedule. Thank you, sir. My thanks to today's guest of honor for refresher course on environmental science, Dr. Dete sir, Director, Academic Staff College, Nagpur, for shouldering the responsibility to our college to organize a refresher course in the subject environmental science. I extend my thanks to Honorable Cherde sir, Principal Sevadal Mahila Mahavidyalaya, to provide a platform to conduct the online refresher course in the subject environmental science. I am thankful to Preeti Dharmik Madam, Assistant Professor, Academic Staff College, Nagpur, for support and coordination in organizing the refreshers course in Sevadal Mahila Mahavidyalaya. My thanks are due to Dr. Praveen Meshram, HOD, Environmental Science, Sevadal Mahila Mahavidyalaya, for his untiring and painstaking efforts to organize the refresher course in our college first time. My heartfelt thanks to Dr. Vaishali Meshram Madam, co-coordinator, and she is also assistant professor Department of English, SK Umate College, for her wholehearted support, encouragement in organizing the refresher course in our college. Lastly, I am thankful to all the resource persons, invitees who have attended the today's inaugural functions of refresher course in the subject environmental science. Thank you, all of you. Now, I would like to hand over the mic to Dr. Vaishali Meshram for further proceedings. Thank you.
Thank you so much, sir. With the consent of the chair and the course coordinator, I now declare that the inaugural session is over. We are going to start the first session immediately. Thank you, and let us embark on this enlightening voyage together. I wish you all a fruitful and productive refresher course. Ladies and gentlemen, we have a multifaceted and a versatile resource person and an ardent learner for the first session, Honorable Dr. Pavan Lapshetwar sir, Chief Scientist and Head, Water Technology and Management, NIRI, Nagpur, in our midst today. I now hand over the proceedings of the first session to the course coordinator, Dr. Praveen Meshram sir, and request him to introduce Dr. Pavan Lapshetwar sir to the participants. Dr. Praveen Meshram sir, over to you.
All the members of the teaching staff, all the invitees, and my dear participants, as we have told you that we all are gathered here for the inaugural ceremony of the online refresher course in environmental science organized by UGC HRDC of Rashtra Sant Tukdoji Maharaj Nagpur University Nagpur in association with the Sevadal Mahila Mahavidyalaya and Research Academy. The entire world is talking about the environmental protection, reducing carbon emission and sustainable development. The root cause of environmental degradation is man's misbehavior of human race with nature under his false ego that he is the master of the nature. We all know that India has signed the Paris Agreement on climate change on 2nd October 2016 and has committed a significant reduction in carbon emission by the year 2030. With this background, we just can't imagine of any name other than the son of our own soil, Dr. Pavan Lapshetwar sir, who is working as a chief scientist and head, Water Technology and the Management Division, NIRI Nagpur, as our today's chief guest. Further, I would like to introduce Dr. Pavan sir that he obtained his doctorate degree from Rashtra Sant Tukdoji Maharaj Nagpur University Nagpur and joined as a scientist in NIRI in the year 1992 and elevated himself to the highest position such as the chief scientist and head in the same institution. Dr. Pavan sir is known for his significant scientific contribution in the areas of environmental impact and the risk assessment, wastewater treatment and the environmental biotechnology. He had also designed and developed the water safety plants, grey water recycle plants in rural areas. Another aspect of his academic talent was found through writing books and publishing more than 150 research papers in national and international journals of the repute, 250 technical reports, and contributing in 15 books. In recognition of his academic and administrative qualities, he was appointed as a water and the sanitation officer by UNICEF at Bhopal, which is an additional feather in his cap. My dear participant, Dr. Pavan sir has a huge list of the achievement and the awards. If I read all of them, perhaps I will be need additional 1 hour. However, just to name a few, Dr. Pavan sir is the recipient of the Commonwealth Science Council Fellowship to participate in training workshop on environmental impact of air pollution held at Brisbane, Australia in the year 1999. Best Research Fellow of NIRI award contribution to R&D excellence during 1991. The division in which Dr. Pawan sir was nominated as the best scientific division of the NEERI in the year 1991 in recognition of its significant contribution. Nagpur Gaurav Samman by Maharashtra Times, one of the leading newspaper of Nagpur city. He is the member of various professional bodies in India and abroad. Visited many foreign countries including the USA, Australia, Nepal to attend and take active participation in seminars and the conferences. Dr. Pawan sir has a pleasing personality and therefore he is successful in establishing and the harmonious relationship with the divisional members of the NEERI in coordinating and conducting various activities. My dear participants, in a nutshell, I would like to introduce Dr. Pawan sir as a personality with a strong problem-solving skills, out-of-the-box thinking, and a great team leader. It speaks the volume of his single-minded dedication that he has organized various national and international level program at NEERI for the benefit of the teacher, student, and the scientist, where he has received an overwhelming response. On behalf of Sevadal Mahila Mahavidyalaya and on behalf of UGC HRDC, I take this opportunity to wish you a good health, happy and enthusiastic life. Sir, it's a matter of great pleasure for us to have an eminent scientist and the environmentalist like you as a chief guest on the occasion of this online refresher course in environmental science. We are really delighted to have you here, sir. May I now request Dr. Pawan sir to kindly take the charge of this wonderful morning session. We all are eagerly waiting for your motivational talk, followed by your presentation. Over to Dr. Pawan sir.
Yeah, good morning, everyone. Thanks, Professor Praveen Meshram, for a kind introduction. Professor Meshram is a very good friend of mine, so he has all the adjectives to talk about me. Yeah, but I would like to thank Professor Meshram, Professor Dethe, and others who had found me suitable to be chair guest today. You might be aware that sometimes if you know someone like Professor Meshram, it's very difficult to say no to them. Though I was busy in one of the very important meeting today in the morning, and we are revising water supply and treatment manual of Government of India, which is treated as a Bible by all those who actually design water supply system. We are almost finalized, but I requested Chairman Dr. Deen Dayalan, who is advisor with the Ministry of Housing and Urban Affairs, to spare me for a few hours so I can be with you. So with this little introduction, I would like to thank and welcome Professor Dethe, Professor Charde, of course, Professor Meshram, who is course coordinator, Dr. Vaishali Meshram, and participants who are teachers, in fact. So I would like to take this opportunity to say impress upon that we are really struggling to manage environment. I work in water and wastewater sector now, but overall, if you look at the problem with the environment is very, very large, and all of us, unless work together, I think it's very, very difficult to resolve this issue. I would also like to congratulate Professor Charde, Professor Meshram, and other faculty members of Seva Dal Mahila Mahavidyalaya for say creating academic excellence. So I would say briefly talk about what NEERI actually does in 7-8 slides before I would say make my presentation on water management. So I will be sharing my slide. I will request either Dr. Vaishali or Professor Praveen to confirm if they are able to see my presentation. My God, cannot share content. So Dr. Meshram, you have to make me presenter so that I can share. I think you have to make me co-host. So I can. I think I can. Just hold on. Are you able to see my screen, Dr. Mishra? Can you please confirm? Are you able to see my screen, Dr. Mishra?
No, sir, no. Yeah.
Yeah, there's like about CSR NEERI. Are you able to see?
No, sir,
There's a
no.
small lag.
No, sir. Sir, screen is not visible.
Okay, I'll try once again.
Yeah, sir, yeah.
It's visible now.
Yeah, now it's visible, sir.
Okay. Is it on slide mode?
Yeah, sir, yeah.
Okay, great. When I was talking to Dr. Meshram, I requested because our director, Dr. Atul Veda, who was supposed to be here, is not here. By the way, he conveys his best wishes to all of you, Dr. Meshram, and participants for this particular course. So I'll be presenting and talking about CSR NEERI in brief. I think I'll take around 20 minutes. And if you have any question, please feel free to ask about it. So just brief about CSI NEERI. It was established in 1958 and it was known as Center Public Health and Environmental Engineering Center Public Health Engineering Research Institute, CEPHERI. So yeah, our motto is to take science to society through our various R&D divisions. So we are like 15 R&D divisions in NEERI, which starts from air pollution control. We have like cleaner technology and modeling, environmental biotechnology and genomics, environmental impact assessment, and energy and resource management. We have health and toxicity. We have 5 zonal centers other than headquartered in Nagpur at Delhi, Chennai, Hyderabad, Kolkata, and Mumbai. We have environmental material division. We have environmental virology cell. We have sophisticated environmental analytical facility which cater to all the scientific divisions here in NEERI. We have a chemical and hazardous waste management division. We have waste processing division, and we also have wastewater technology division. And I had this water technology and management division. So we cover almost all the facets of environmental science and engineering in NEERI. So our core competencies in air pollution control, cleaner technology and modeling, energy and resource management, environmental biotechnology, environment and materials. And our current activities include bioremediation, climate change. We also have COVID test center, which we started way back in 2020. We have ecosystem service mapping and valuation. We also carry out this environmental management plans. We prepare environmental status report for Nagpur Municipal Corporation. We have prepared this environmental status report for entire Nagpur Municipal Corporation area. We also evaluate and audit hazardous waste systems. Other green firecrackers also is the area in which we work. So there are many areas in which we work here in NEERI. And we also contribute to national goals and mission through our flagship program. So in Namami Gange, we in fact have contributed a lot. We monitored water quality right from its origin in Gomukh up to its confluence in Ganga Sagar. So we covered special properties of River Ganga. We have monitored river quality, of course, and we also contribute to Ganga River rejuvenation. Similarly, we contribute in Swachh Bharat mission through our water treatment technologies and wastewater treatment technologies. Similarly, Swasth Bharat also factory for sewage treatment. We have this particular sewage treatment technology. We also work on air pollution control, which indirectly contributes to Swachh Bharat mission. We also are part of smart cities through, say, water safety plan preparation, lake restoration, and all. So as I told you, we contribute to various, say, national goals, missions, and flagship programs of Government of India. If you look at say our contribution, we are like 62 plus years of leading in environmental science and engineering. We have worked with 30 countries. Our project locations are in 30 countries. We have completed say 2,400 projects since our inception. We are 280 employees, out of which 115 are scientists, and we're like 35 technical officers. We have 2,100 scientific publications. We have 180 patents granted. We have developed 50 technology, and of course, it's one-stop environmental solution. If you see the publications also, we have really risen significantly since 2018, wherein we published, I think, 134 papers, and our total cumulative impact factor was 437. And in 2022, we have published 240 papers, and our cumulative impact factor was also increased to almost 1600, which is very, very significant. So this is just in brief about water technology and management division where I work. So I told you we work on various water treatment technology, and one of the technologies electrolytic defluoridation, in which we remove fluoride from water. In addition, so these technologies have been implemented in almost 400 fluoride affected areas in India. We also contribute to Institute Dilution for Fluoride. This is a school near Chhindwara in Madhya Pradesh, wherein through roof water recharge, we could bring down fluoride concentration from 7.5 mg per liter to less than 1 mg per liter. As I told you earlier, we work on water safety plan, and one of the group here in our division also works on groundwater management, and then this we have very sophisticated instruments like ground penetrating radar, and we also say work on hydrological impact assessment and modeling through solid transport studies. And we are one of the few laboratories in India where we have say installed this flux tower in critical zone observatory, when we monitor various say weather parameters as well as parameters like soil moisture. So this is in brief about what we actually do. So Dr. Mesham, should if there is any question from any participant, I can talk more about DD. Otherwise, we can switch over to my presentation. So anyone from participant, if they would like to know more about DD, यदि आपको कुछ और जानना है तो मुझसे पूछ सकते हैं. Otherwise, मैं अपने presentation की ओर बढ़ता हूँ.
Sir, I am having a not problem, but want some discussion over the problem that Australia is surrounded by all the water, but still also some cities are there. They are just declared as no water zone. Why it is so? Means what happens to means why they are declared as zero water zone?
In where? South Africa.
Australia, sir. Australia.
Australia, I doubt. Australia, the population is very low. Yeah, what happened if you see the geography of Australia, the central part is desert, so it hardly rains over there. So that's why the central part might have been declared as say water scarce area. But the coastal area, particularly the say northwest side, even the western side, like Perth and all, a fairly good water supply. Moreover, what happens, they are very good in water management. So in addition to using the available water over there, they treat and reuse their wastewater also, which is added to their say surface water sources. So they're very good in water management. Yes, I agree that the part of the Central Australia or even North Australia, there are some issues related to water scarcity. That's why the part has been declared as say water scarce or water deficit area. But I feel that the problem is more pronounced in South Africa than in Australia.
Australia, sir. I am talking about Australia only.
Yeah.
Australia,
So-
area in Australia.
Yeah, that's the only reason, because it's desert in the central and say north part of Australia. It's desert, so that's why they might have declared that as water scarce area.
Thank you, sir.
Okay.
Thank you.
So I'll move to my presentation, Dr. Meshram. Okay. Can anyone confirm if you are able to see my slide?
Yes, sir. Not
Okay. So what I'll do is so I'll take around say 45 minutes, and then we can have a bit of discussion. So I'll be talking about water quality and quantity. What are the management options available? As Madam has just asked about water scarcity, we are facing a lot of problems in India also. So we'll focus more on say in India and try to see that what best we can do. Moreover, I would also like to have your inputs that how can we move forward, हम कैसे आगे बढ़ सकते हैं और देख सकते हैं कि हम हमारा जो water resources है उसको किस तरह से manage करें. So this is my outline of presentation. I'll be talking briefly about what water is, water quality. You might be aware of it, but let us say discuss. So this will be more of say knowledge exchange than actually going telling you what water management is. What are the sources of water pollution, and what are the different water treatment options which we are exploring, and what are the options available to us in near future. So I'll talk about conventional water treatment, how the water is treated in the treatment plants. We have like 3 treatment plants in Nagpur, and they're called as Bench 1, Bench 2, Bench 3 in Goregaon. I think I could see Bharat also, as she is more aware of it. And what are the treatment for say various geogenic contaminants like fluoride and arsenic? So we'll even talk about it. And if we properly manage water quantity, I'm sure that we are going to even manage quality. So we'll discuss these aspects in my presentation. There's something known as a preventable water contamination. What is actually happening in our country, or see elsewhere also, we first contaminate our water sources and then try to treat that. So if we can prevent water contamination, we then don't need to treat them. So this is a picture which I taken in a place in a village in Orissa. So can anyone tell that we can get safe water from this source? Please feel free to say comment. As Professor Dethe expected you also to be part of this say lecture series at say refresher course. I'm sure that you will also contribute. So can anyone tell me, because I will be asking questions to you. It's not that I'm going to simply present. So can anyone tell me, यदि कोई मुझे बता सकता है कि ये जो हैंड पंप आपको दिख रहा है उससे पानी साफ मिलेगा? जब तक वहां से आवाज नहीं आएगी तो मैं चुप रहूंगा सर.
Sir, please repeat the questions. Sir,
My question is,
Sir, your screen is not visible.
Are you able to see the photograph? No?
No, sir.
No, sir, it is not.
No, sir.
Now, no, is my screen moving?
No, sir.
Okay, then what I'll do is, are you able to see anything? No.
No, sir.
No, sir. No, sir.
That would, I think, restart. Hold on. Good. Is my screen visible?
No, sir.
Sir.
No, sir.
Yes. Now I'm.
It's
Ah,
visible
yes.
now by screen.
sir.
Yes.
Yes, sir.
Yes, it is visible.
I think there's some small lag. Okay, I'm loading my presentation. So once it is loaded, please confirm it. So are you able to see my presentation now?
Yes. Yes.
Yes.
Okay, great. So I'll try to put it on my on slide mode. Just confirm once it is in slide mode. Okay. Is it in slide mode?
Sir.
So are you able to read this title of the presentation, water quality and quantity management options? Are you able to see my first slide?
No, sir. No.
No, sir.
What are you seeing? Means, are you able to see the first slide or the are you able to see my screen at least?
Yeah.
I
Yeah.
can able
Yes.
to see the screen, sir, but the PPT is not open, sir.
PPT is not open.
Yes, sir. Yes, sir. It is showing the list of PPT, sir.
Oh no. So there's considerable. Okay. I don't know. Are you able to see the slide water quality and quantity management options?
No, sir.
No, sir.
Okay, what I'll do is.
So only we can see is the folder names, in a very small icons.
No. I think there's some problem with it. Okay, let me stop and reload. Just. So that's the problem with WebEx. I never trust WebEx. MS Team is much better. So are you able to see my screen? I'm sorry to really request you several times, but unless I am able to show my slide, there is no point in going ahead. Are you able to see my screen?
Yes, screen is visible, sir, but only we can see the folder names. That is in a very small icons. It is not clearly visible.
Yeah, I'm just. So are you able to see this?
No.
PP presentation? No, not
No,
yet.
no.
I don't know. The first one you could see. I'll do is I'll unshare
For a
again.
moment it was there.
Oh, is it? Okay, so I think we have to wait.
Yes, it's visible, sir.
Oh,
It
great.
is visible now.
Yes, sir. Yes.
So is it in presentation mode?
Yes.
Yes, sir.
Great. Okay. Sorry for this hiccup. It should happen. So okay, well, I'll restart. So water quality and quantity. What are the management options available in India for us? So are you able to see my second slide outline of presentation?
Yes.
Great. So I think it's fine now. I think there shouldn't be any more trouble. So this is outline of my presentation, introduction, water quality. What are the sources of pollution? I'll be talking about water treatment, both conventional water treatment plant and water treatment for geogenic contaminants like fluoride and arsenic a bit. and how the water quantity can influence quality. So this is preventable water contamination. So, okay, I was on this slide. So this slide is available in which a hand pump is shown.
Yes.
Okay.
Yes, sir.
Yes, sir.
So
It
my,
is.
Yes, sir.
It is visible now.
Yes, sir.
okay, great. So my question to you is, this is the say photograph which I took, I think 15, 20 years, almost 20 years back in a village in Orissa. So we had this type of source. So can you imagine that we will be able to provide safe source from this particular safe water from this source?
Not at all.
Yeah, what's the reason that we are unable to provide safe water from this particular source? So what are the risks you can see here which can actually contaminate water? What's the risk?
Sewage water, sir.
Yeah,
May I answer?
yeah, please.
Yes,
Anyone?
sir. Farhat here, sir, from OCW. So actually, the condition we are seeing over here, it is quite very polluted kind of a things. Though the other kettles are also there and the underground dripping is there, so that's the reason maybe the water level got contaminated and it is directly coming to our drinking water. Another thing is that which I have already witnessed and due to that severely affected, that I think there is one chemical, fluoride or chloride, I don't know the exact word, but that is affecting the teeth quality. It is giving the yellowish shade to the teeth and the entire generation got affected.
I will try you to focus on this particular photograph. So,
Yes.
Thanks.
And
Yeah, thanks.
unhygienic condition also the major threat in this photograph.
So, okay. So you feel that this contamination is preventable. We could have prevented this contamination. Because the groundwater here, if you go some 10 meter, 20 meter from the source, the groundwater is fairly safe. But you can see pigs around us. Drainage channel is like it's almost blocked. You can say the wastewater getting accumulated here, which ultimately say goes back to groundwater. People are washing their clothes and utensils. So this leads to contamination. This can easily be prevented. Okay, thanks. And this is a very sad story. And then I don't know, you might have missed this story also. So one student died, 35 male in Rajasthan's Kota, polluted water likely cause. NEET aspirant dies of liver infection in Kota. So this had happened in October 2022 when a famous coaching institute in Kota had this water contamination. And these 41 students were actually admitted to hospital, and one student from West Bengal, he unfortunately died. And the reason was that the water which this hostel in which these students were living, they didn't have any treatment system. A treatment system, if they had, was not functioning at all. And when the investigation was done, they found out the source of water was a tanker. So this hostel was getting water from a tanker. And then the further investigation revealed that the tanker was filling up this water to supply to the hostel from a bore well. And the bore well was adjacent to a wastewater drain. And that had contaminated water, and these people, these students had in fact had hepatitis jaundice. So this is the fate of say water management in our country. This I'm sure that these are like very distinct examples. We are trying to manage our water much better way, but these are the distinct examples which clearly show that we have to really do much better than what we are now doing. So these are two examples which clearly indicate if we manage or prevent contamination, we don't need to treat our water. So that's what I wanted to actually tell you. But in some cases, the lady before also talked about we need to necessarily treat water in many instances. So this is what I think, madam, you talked about. This is what. Can you please come back again? You were talking about this teeth getting affected. What is this? Okay, this is a common question to all of you because you are from environmental science background. What is this? What are these cases? Anyone? Can someone tell me what is this?
I think these
Sir,
are
fluorosis,
disabilities
lack
kind
of-
of things.
Huh?
Fluorosis, sir.
Yeah, what is this?
Some kind of
What actually-
disabilities and teeth disorders.
Yeah. Why are these children having, say, mottling teeth, or if you see this leg like this, what actually
So it's
causes
due to
this?
fluoride
excess of
contamination in
fluoride
water.
in water.
Yeah, excellent, excellent. So because it's occurring naturally, we need to treat it. Okay. So I'm just coming to it. But we have fortunately launched this program, Jal Jeevan Mission, and then the basic objective of this particular program is to provide Har Ghar Nal Se Jal by 2024. We have financial outlay of 3.5 lakh crore. And the objective of it is to provide functional household tape so that whatever pictures we have seen earlier won't be there. Water resources management by the Gram Panchayat, and key focus of this particular mission is on water conservation, source sustainability, rainwater harvesting, and groundwater treatment. And most of the schemes are single village groundwater based schemes, and there are few multiple village schemes in dark or exploited blocks where groundwater is not available. So I'm sure that once this mission is implemented, I'm sure that there'll be some issues. But with this particular mission, we really want to overcome the problems which I have earlier shown to you. Okay, coming to water quality. So, like water quality parameters, they can be divided into physical, chemical, and microbiological. Then physical also include gases and solids, chemical, organic, and inorganic. Whereas microbiological have pathogenic and non-pathogenic. Solids can further be divided into floating, settable, collided, and dissolved. Easy to remove. So I'm trying to build the case, so I'm sure that you are aware of it, but just bear with me for some more time. So water quality parameters, if you talk about physical chemical parameters, we can like odor, color, temperature, turbidity, and we like sulfate, nitrate, and fluoride. And then these sulfate, nitrate, particularly nitrate and fluoride, have health repercussions. They directly affect health of human being. Similarly, demand parameters, dissolved oxygen, biochemical oxygen demand, and chemical oxygen demand. Similarly, microbiological parameters, E. coli, fecal coliform, like pathogenic bacteria, protozoan viruses, which have like significant health impacts. In addition, we have elements in metal like aluminum, arsenic, cadmium, up to zinc. They are found naturally as well as through industrial discharges. We have many toxic compounds, pesticide, pharmaceutical, and personal care products. They are of say recent origin, and they are like micropollutants, and then aquatic biota, phytoplankton, and zooplankton. And these are the health effects of contaminated water. Boron affects nervous system, mercury also affects brain, fluoride causes discoloration, damage to teeth, which you already seen. So I'm sure that you are aware of it, so I'll not go much into it. But I'm now coming to natural sources of water constituents. So what happens even if we don't have any contamination source in our catchment, particularly I'm talking about surface water sources, and even in groundwater sources where there's hardly any, say, industrial discharges or sewage from cities, there's a water rock interaction, and which is the primary source of calcium and magnesium and bicarbonate to our water. The atmospheric deposition of nitrate, of course, but nitrate is mainly contributed by wastewater sewage. Sodium in groundwater is from granitic rock, whereas potassium is contributed from orthoclase and muscovite minerals. And chloride from natural sources such as rainfall dissolution or chloride bearing minerals. So we like a lot of chloride bearing minerals. So water moves through this catchment, it contributes. disturbance of riparian vegetation result in increased sedimentation. So turbidity actually is caused by this disturbance of riparian vegetation. So it's a natural contaminant. Whereas dissolution of gases H2S and methane, which can occur naturally also due to biological degradation, that also gets dissolved in water. Iron and manganese from these reservoirs. So you might be aware that iron and manganese, particularly in very deep surface reservoirs, they settle in the background, settle at the bottom, sorry, and as there is an aerobic condition, the iron and manganese are normally in reduced form. And then once the water is pumped from this bottom of surface reservoir, and they come to treatment plant, and whenever we have like aeration, they oxidize and settle in the distribution system itself. And they're microorganisms of animal result. And in addition, the last one is fluoride, arsenic, and other metals which are contributing naturally. So even if we protect our catchment, what we actually mean is that we need to treat water so as to remove some of these contaminants like iron and manganese, dissolved gases like turbidity. That's what we do in our conventional water treatment plant. So there was a study done way back in 1963, and it was a world average of and then the water quality of River Ganga also was considered, and you can imagine that it's almost unpolluted. So you can so that we can conclude these industrial discharges or sewage discharges from cities contribute a lot in making our water polluted. You can see that calcium, magnesium, potassium, and sodium also at very low concentration, and ions like bicarbonate, sulfate also is very, very low. So I have a question to you. So you have been asking questions to your students. So I'll ask question. Can you name 5 things that dissolve in water? Any one of you? So I have shown you suspended solids and dissolved solids. So can you kindly tell me what are the 5 things which can get dissolved in water? Any one of you?
Sir, I can say salt, sugar, honey.
Oh no, I'm talking about this anions and cations.
Okay.
Like conventional pollutants are conventional elements. Soil, sugar, honey, they're different.
Sodium.
They are combination of elements. Anyone of you?
Sodium,
Sorry,
arsenate.
sulfate, nitrate. It's fluoride anion there.
Excellent.
Fluoride.
Yeah. And pollutants. So fluoride and nitrate. Okay, fine. I'll move forward. Oh, this is a small quiz. So figure out some pollutants. The first one, I'll be very happy if you can decode this. What is this pollutant? So if
First one is
what is
carbon
this?
dioxide.
No. So
Carbon monoxide.
Huh?
Carbon monoxide.
No. Okay, this is very small. These are cars. So how do you spell car? It is C-A-R. Okay. So in the spelling of car, you have to delete this C. So what is left? A-R. Got my point?
Arsenic. Sir.
Very, very good. Very, very good. Excellent. And this is?
The
This is night.
night.
I need to delete GH.
GH.
It's very simple.
Nitrate.
Very good. Very correct. Excellent. So this is actually rate.
Rate.
Rate. And this is what?
Right.
Fluoride.
All right, very correct. Okay, excellent. I'm sorry, I'm I wanted to keep as simple as possible, so I'll try to move to slightly complex things later. Okay, to come to sources of water pollution, yeah, I think this clearly gives what might be the possible pollution sources, and you can see the like commercial and animal fertilizer fodder, which is contaminating groundwater aquifer. Similarly, urban runoff, septic tanks, sewage treatment, and the industry is contributing to, say, nutrients in water, underground storage tanks that also contribute to water contamination. So this in nutshell shows what are the possible contaminants. Yeah, can someone from Nagpur identify this place? And which is this river?
Nag River.
Nag River. Yeah.
Nagri.
Yes, yes. This is very close to Dhantoli. So we did sampling here to find out what is the concentration of PPCPs, pharmaceutical and personal care products, because this is downstream of all those hospitals which we have found that dumping their, say, expired medicines here. So you can imagine there are many sources which actually leave the rivers like this. And this is, yeah, Bharat is there, I think. So this is conditions near Intekville in Kanhan. So you can imagine that what sort of water actually comes to a treatment plant. Yes. Yeah, I think it's much better now. This photograph was taken some 10-12 years back. So this is fenced. So you can imagine that we are finding it very difficult to actually say conserve our sources. So what my point is that if we can prevent our sources getting contaminated, we can easily manage. You might have not gone to these intake wells anytime, so you're not aware that was some situation. So I had another presentation of water safety plans. Really fast contaminate our water sources and then try to treat it. See, this is the situation in Agra Waterworks. So you can see that BOD should be less than 3. So like 9, 12, 16, 27. So we have like biochemical demand of 27 mg per liter, COD of 46 mg per liter. This DO is wrong, but chlorine demand, you can see that 25 or 35 mg per liter. So this raw water quality is fed to water treatment plant in Agra. This intake well is on River Yamuna, and you know that how badly it is maintained. So the conventional water treatment plant, which is used to supply water to Yamuna, has now been upgraded to treat wastewater also. So what my point is that we are really first degrading our water sources and then try to find out how can we treat this water. This is another issue. So we had faced this in Nagpur in 2017 or 18, and in August, in fact, when there was hardly any rain, so there was algae you can see in our river water, which was fed to the cascade aerator, and you can see entire water green. So Kanhan water, river water changed to greenish color due to very fine colloidal particles of algae. So our conventional water treatment plant is not meant to remove this algae to this extent. Chlorine demand increased from 0.15 mg per liter to 1.7 mg per liter. At some places we have seen the chlorine demand had increased to even 10 mg per liter, and then PAC dosing was also of that order. And these very fine particles of algae couldn't be removed at water treatment plants. So can anyone tell me that how this algae get formed in any river body? Anyone? I know I'm asking some of the simple questions to you, but let us recap instead of say going into much detail of those complex water quality issues. Can anyone tell me that how the algae is formed? Okay, what are the contaminants which are needed?
It's due to photosynthesis. Photosynthesis of that photosynthesis. Due to the photosynthesis there.
Yeah. But what are the primary
algae
elements?
can make their own food.
Yeah. But what are the primary elements which are needed for algae formation? They are nutrients, you know that your NPK in waters. Once the sewage is discharged to such river body, the NPK is there, the carbon is there, and then algae, as someone rightly pointed out, through photosynthesis can generate. And then we find it very difficult. It's not in Nagpur, but possibly in many of the treatment plants, we are facing such problem, particularly in summertime. And then we are adopting some, say, ad hoc measures to provide safe water to the citizens. And this fish kill in Nagpur also that was observed in 2019 near Ambadri Lake, and you can see the fishes floating on this Ambadri Lake, and this is also due to say cyanobacteria and then algae, and then you are like algae leads to say diurnal oxygen cycles, and DO or dissolved oxygen was depleted to the level of less than I think 3 to 3.5 mg per liter, when there was so much of demand of oxygen by these algae, particularly late in the evening, and the DO was so low that this fish kill occurred. And this is happening not only in Nagpur but at many places, Chandrapur, or even if you go to places like in Rajasthan, you'll find such fish kill. So these are like emerging scenarios in India in many water bodies because we are not properly maintaining it. So we were really conversant, or we were comfortable with those conventional water contaminants, but we are now getting some of these contaminants which we find very difficult to handle in our treatment plant. So we are really struggling. Yeah, this is a very, very important story of Nagpur itself. You can see this is the river Kanhan, and this is our intake well, which was constructed, I think, in late 60s, 1960s, from where we draw water, almost 200 ml of water we draw. And then upstream of this ash pond was constructed by Koradi Thermopower plant in 1980s. And that time, if we could have not constructed this ash pond at the upstream of our intake well, we might have prevented several say accidents which took place later. You might have also heard in 2017, 19, even in recent past also, once this ash pond reaches this water, supernatant from this ash pond also gets to our Kanhan River intake well. So these are like preventable contamination sources which I'm talking about. So when we monitored this, there was a breach, and then this had 7.6 mg per liter fluoride. It also had like arsenic at some time. You can imagine a river which is flowing silently, and we somehow construct this. So you feel this is a right decision to construct ash pond at the upstream? Anyone? I'm waiting for the response. Is this wise to construct this ash pond at the upstream of intake well?
No, not at all. It is very dangerous.
Yeah,
and also to the everybody's life.
Yes, it's very correct. So we should have located it somewhere else, maybe in downstream or somewhere out of the range, so that our river could have been, say, kept as it is. And this was the situation in close to intake well. So this is like muddy.
Yes.
So I was talking about list of most widely prescribed drugs, analgesic, and then like antibiotics, cardiovasculars, and then we like SSRIs, anti-diabetic, metformin, and all. So we did a study in river Nag and found out that these drugs are available in our water at very, very high concentration. So we were talking about all those like very preliminary or basic contaminants like turbidity or total dissolved solids, and we are aware of nitrate and fluoride. Then we came to algae, and now we are talking about these PCPs, like personal care products, Clasana, methyl parabenatol, which are part of soaps, so many cosmetics we nowadays use. So these are also emerging as the contaminants which can affect us many ways. First of all, they remain in water for very long period, and they hardly get degraded. So these are also pollutants of major concern to us. So we did this study in which we monitored and then tried to find out what are these levels, and these are much higher than sulfur. So my point is that okay, we are finding it ourselves difficult to handle those traditional pollutants, whereas now we have contaminants which are also coming into our waters. How should we actually prepare ourselves so that we can properly treat them? Okay, we'll take a small pause here. I would now like to know pollution sources you normally encounter for both groundwater and surface water. So can anyone share your experience? So I have shown so many things. I have shown you Nag River, I have shown you, pardon? Yeah, please go ahead.
Washing clothes with detergent near river areas. This may be a.
That is domestic waste, agricultural waste.
Agricultural waste is real concern, very true. Yeah.
Using fertilizers.
Industrial waste.
Yeah,
Industrial effluents.
Yeah.
Sir, immersion of idols during Ganesh Visarjan and all.
Yeah, very true. Yeah, so you can imagine that we keep blaming Nagpur Municipal Corporation for that, not even Orange City Water, but the type of pollution they get, which is created by us, they find it very difficult to actually treat their water. So public awareness and all those preventive measures are much important much more important than treatment, I feel. Great. So try to move to water treatment, conventional water treatment plant. I'm sure that you are aware. You might have also seen some of the treatment plant, but let us recap. Okay. So if you go to any conventional water treatment plant, which is normally considered by our municipal corporations, urban local bodies, we are like aeration. This is the first unit. Then pre-oxidation, where we use chlorine for oxidation. Then we like coagulation, flocculation, sedimentation, filtration, and disinfection. So through this, these conventional water treatment plants are constructed to remove the naturally occurring contaminants, and the two of the contaminants which we normally remove in our conventional water treatment plant are turbidity and microorganisms. So these two, because they are natural. So I'm talking about surface water sources here. I'm not talking about any fluoride and arsenic in our water. I'm just talking about the river water, which hardly contains any say fluoride or arsenic for it. So we like aeration, which helps in removal of this volatile organites, and these volatile organites cause taste and odor, and there are some dissolved gases. I have told you that H2S and methane get dissolved in water. So once we aerate this particular water, this methane and H2S also get oxidized. At the same time, the iron and manganese, which sometimes are present in our reservoirs, that also can be oxidized, and then they can easily be settled in the subsequent treatment units. At places we use pre-oxidation using chlorination, which actually retard microbial growth and also oxidizes taste, odor, and color, causing compound. In some of the water treatment plants, particularly in Delhi, places like Delhi, they don't have this aeration unit. So they have no option but to go for pre-oxidation using chlorine, and that helps in removing these contaminants. But it has its own problem also. Then we have this coagulation, flocculation, and sedimentation, and this is to destabilize colloidal particles. And the flocculation unit, we aggregate these destabilized colloidal particles. They are negatively charged particles, and then through some some chemicals like polyaluminum chloride or alum. We destabilize these colloidal particles and then we bring them together, and then we, through gravity separation, remove this this colloidal particle flocks. Similarly, at the end we have a filtration in which these suspended particles, solids, which are sometimes not removed using these coagulation formulation processes that we use that we remove by using filtration. And at the end we disinfect primarily using chlorine. So we are discussing, instead of chlorine, if we can use other disinfectant also. So at this time, can anyone tell me what are other disinfectant agent we can use in addition to chlorine? Sir or madam, what are other disinfection processes which we can use to remove these pathogens, bacteria and viruses?
Use of UV light.
Correct.
Boiling.
Boiling, yeah, but pardon?
The boiling is means very easy and convenient at home levels also.
Very
Boiling of
So, have you heard of ozonation? The ozonation was also getting introduced because several limitations of chlorine.
Yes.
Yeah, ozone is also. So when we are writing this manual, and in which ozone will also be, the only disadvantage of ozone is it's expensive process. Otherwise, it's much. It's also a very good disinfectant. Can anyone tell me what's the limitation of chlorination? There's an issue with the chlorination, which really is getting highlighted, and the people, particularly in Western world, they feel that the chlorine should not be used.
feeling of dizziness.
Pardon?
Feeling of dizziness, drowsiness.
Yeah, that. It's just, if we get exposed to chlorine gas, then we can feel. But chlorine, what happens? Yeah, you go ahead, madam.
Yes, sir. Please pardon, sir.
Yeah, you can. You are. I think you were telling something, and I just intervened. So what I meant is that you can go ahead and speak.
Okay.
Okay, but I think you might have also read that there's something known as a trihalomethane, a disinfection byproducts. So we have, say, natural organic matter in our water, which are like, these compounds are tannic acid or other fluvic acids, that they are contributed to our water through natural sources. So vegetation actually contributes to that. And they react with chlorine to form something known as like trihalomethane or haloacetic acid. And these disinfection byproducts are carcinogenic. They are proven carcinogenic. So we now trying to, the world, particularly Western countries or developed countries, they are trying to phase out application of chlorine for disinfection. But chlorine has another property. Can anyone tell me what's this property of chlorine, which is very useful, particularly in places like India? So there's something known as a residual. So what happens now if we leave residual of 0.5 mg per liter of chlorine in our water? So that continues throughout our distribution system. So in case if there is any contamination in our distribution system, this residual chlorine take care of that. So that's why chlorine has that advantage, whereas this ozone can last hardly for half an hour or even 15 minutes to 30 minutes. And then if we don't have any residual disinfectant in our water, the water, once it starts from treatment plant, it goes to our balancing reservoir, elevated surface reservoir, travels through our distribution system. and during its transit from treatment plant, it gets contaminated. So we need some residual disinfection so that we can take care of this contamination. Okay. So yeah, this is what I was talking. Test and odor causing aeration is the unit. So these are the, say, water treatment units in conventional water treatment plant. So this is like a schematic of the. So we like cascade aerator, we like a flash mixer through which the coagulants are added. Then we like clariflocculator, and that's put. Then there's the settled water is routed through represent filters, battery of represent filter, and at the end we chlorinate or disinfect water. So this is like conventional water treatment plant schematic. Just show. Okay. So this water source, we take water source to first treat aeration unit, then we take it to coagulation and flocculation, or we can take it directly after this flash mixer to clariflocculator, and the sedimentation takes place, and then we like filtration, and then at that disinfection. Okay, and storage and distribution. This is the like typical layout of any water treatment plant. Okay, coming to this unit of aeration, as I told you, so when oxygen is infused to it, the manganese and this iron are extradized, and it's while this manganese in reduced form remain dissolved in water, but once we extradize it, particularly say extended aeration, then it can easily be settled. Similarly, the dissolved gases that also through this aeration unit can be vaporized, can be eliminated from water. So this aeration is normally the first treatment unit in any conventional water treatment plant. This is very important unit, coagulation, flocculation. So this helps us in removing the colloidal particles. They're normally inorganic in nature, so we add this coagulant, which is polyaluminum chloride. And earlier days we used to add some this lime also to our coagulation and flocculation. So raw water enters here, then this coagulation we do it, and then after that we even add sometimes coagulant add, which helps in improving performance of this coagulation flocculation. And then this in clariflocculator, where the water is fed, and then the particles is settled, and then this sludge can be released. So in the first unit in coagulation, because these colloidal particles have a negative charge, so that's why we use this aluminum-based or iron-based coagulant, which are positive charge. So that this aluminum or iron coagulants, they destabilize these colloidal particles, and then in this particular flocculation unit, these particles are brought together by slowly stirring the water. This is flocculation, and ultimately once the flocks are large, then they can easily be removed in settling time. So this is the principle of coagulation, flocculation, and sedimentation unit in any treatment plant. So this is how it looks like. You might have seen these clariflocculators, very big. This arm moves. There might be some flash mixer over here, and then this flash mixer, through flash mixer, we add a coagulant to water. And this is a very important unit, represent filter unit. So after the water is settled, I have shown you the unit before this, and then the water is fed to this particular represent filter. And this is wash water tank. What actually happens in this is that we open this knob first, and the water is allowed to enter through this. Water comes from air once and then we keep these knobs closed. This one closed. This one closed. Whereas we keep it open. So what happens once the water enters, it goes here. It comes from filter media, support media, and gravel, and we keep this open, and the water gets into clean water tank. But over the period, what happens? this turbid particles clog the filter media. And unless we wash this media, there will not be any water passing through this rapid sand filter. So in that case, what happens now? We close this knob. We even close this particular knob, and then we open this knob, and then water flows through this. It comes from here, and then we open this, and then this flows through this. Okay. But this is known as the backwash. So this shows the size of the media, and this is, I think, very old technology which we now also use in our treatment plant. And then the gas chlorination. So nowadays we started using gas chlorination. So this gas cylinders normally come to treatment plant, and they were like manifolds and pipes. So where the water is, this chlorine is fed to water treatment plant. Is this clear to you? If you have any question, you can ask me anytime. Sir, madam. So before I move to water treatment technology, I would request you to name few of these water treatment technologies. So I've shown you some of the technologies which are used in conventional water treatment plant, but other than that, we have many water treatment technologies. So can anyone name few of these technologies? We are just coming close to the lecture, and then we'll break, and then yeah, my lecture will go. So just I'm sure that you're tired, and I'm also. Can anyone name few of the technologies?
RO water.
Zeolite processor.
Yeah, very correct. Yeah. Adsorption. So zeolite we normally use as an adsorb.
Flocculation.
Which one? Yeah. I'm sorry, if you can kindly be slightly louder. RO is fine, like membrane technology is fine, adsorption. Okay, fine. So I'll move forward so that we can close early. So for disinfection, chemical ozonation, there's something known as silver ionization. So use electrolytic processes.
So reverse osmosis.
Yeah. So that also is important. So these are some of the disinfection technologies which are used. And then geogenic contaminant adsorption, somebody told zeolite, and it's a really good adsorbent. Then some ion exchange coagulation precipitated in the iodida, and RO you talked membrane. So these are the major technologies which normally are used to remove geogenic contaminants like fluoride and arsenic, namely. But they are even used to remove conventional treatment. Like you might have heard of ultrafiltration, so that is used in place of rapid sand filtration, which I showed you earlier. So this is ion exchange, require optimization of pH of water. So this is so we are like ion exchange media, which are normally polymer. So like polymer chains, and there are some cross links between two, and we are like functional groups which get replaced. So you might have heard about hardness. So when we treat hard water, so calcium and magnesium, they are replaced by sodium in treated water. So this is the ion exchange with these ions get exchanged in this particular process. But we have to regenerate. So suppose if we are removing calcium and magnesium, and then this particular media then will be full of calcium and magnesium. So we have to use like NaCl to again regenerate these functional groups like sodium. So that the media can be reused. So this is like a very simple process, but normally are being used for making water soft than hard. Adsorption, yeah. So this is a major process now, and then this is being used a lot nowadays to remove particularly arsenic at all. So this is, I think, similar to ion exchange, where dissolved substances are known as adsorbents. They accumulate on the surface of a solid material, which are known as adsorbent. So this might be because of chemical reaction between two. So that is known as the chemisorption, and when physical bonds between the adsorbent and adsorbent. So if the adsorbent and the adsorbent are in contact long enough, an equilibrium will be established between the amount of adsorbent absorbed and the amount of adsorbent in solution. And the equilibrium relationship is known as an isotherm. So I don't know whether you learn this isotherm or you teach students. Otherwise, yeah, we can. So as pardon? Yeah, is there any question? Okay, I think somebody might open mic inadvertently. So there's something known as physiosorption, where the adsorbent get absorbed on adsorbent due to physical forces such as van der Waals interactions. There's something known as London dispersion dipole. A chemisorption, chemical bonding involving orbital overlap or charge transfer. So this can also happen, in which the adsorbent can chemically react with adsorbent, which I explained in ion exchange. So yeah. So physiosorption is reversible, but this is irreversible. So unless we do regeneration, okay. But there's so much of advancement and absorption technology, particularly for fluoride. So it started way back in 1930. So 1990, we were talking about capacity of absorbent of around 5 mg per gram of adsorbent. So that has increased beyond, say, 1990, particularly after 2000, to a substantial range of 25 mg of pollutant removal per gram of, say, adsorbent. So such adsorbents are there. So you might have also heard of activated alumina. So that can remove almost 3.5 to 4 mg of fluoride per gram of activated alumina. Similarly, there are new adsorbents coming up, which can remove, say, higher concentration of adsorbent and pollutant per gram of media. So these are like tricalcium phosphate, calcium chloride modified natural zeolite. So somebody talked about zeolite. So yeah, of course. So this is about membrane processes. Yeah, we are like, if you can see the dissolved fraction, which is from 0.0001 micron to, so almost say 0.1 micron, and then suspended from 1 micron up to 1000 micron. So we can go for like particle filtration or rapid filtration type of filters, which I showed earlier. But for removal of say smaller particles, we need ultrafiltration membranes. After that, nanofiltration, which can remove up to 0.001 micron. And this is reverse osmosis, which can literally remove everything from water. So this reverse osmosis membrane can allow only water to pass through. So which is even smaller, say, ion size. So this is the chart which helps us in selecting proper, say, membranes to remove type of suspended or dissolved pollutants in our water. So metal ions fall in that category. Aqueous salts is from 0.01 micron to 0.001. So the bacteria. So that's why we use ultrafiltration. The pore size is 0.01 micron in ultrafiltration. So bacteria can easily be removed through ultrafiltration. So we started using ultrafiltration in our household water treatment units. You might have seen, say, RO units in our household. But in addition, we like ultrafiltration filters also, so that can remove bacteria. Whereas reverse osmosis can remove literally everything, but it requires a lot of say a lot of energy. At the same time, we use almost 60 to 80% of water in RO. there's a lot of development which has also taken place in membrane-based technologies, not spent. There's something known as a hydrodynamic cavitation. This is a recent technology development, and this cavitation occurs by pressure variation in the flowing fluid or due to the presence of throttling devices such as venturi orifices. So what actually does, you might have seen the nozzle spray. If we push water through this nozzle spray, say it helps in creating vacuum or very, very high pressure also at the same time. And that actually helps in killing these microorganisms. So this is getting practiced nowadays in some of the treatment units, particularly even large treatment units in wastewater treatment plant. Capacity deionization, I'll not spend much time, but this is to overcome limitation of reverse osmosis, in which we say use a lot of water. In this, we use two capacitive electrodes, normally made of graphite, and they are charged also negatively and positively, so that these positively charged ions can negatively charged ions can go to either electrodes. So this helps in removing these particles from water. The fresh water can be collected here, and this doesn't lead to, say, loss of water. So capacity deionization, it's a slightly, say, expensive technology being developed now, but we don't have many, say, treatment plant based on technology in the entire world. So just come to last few slides. We have done some study in Gadchiroli district. So if somebody who is aware of Gadchiroli district, they might be aware that we don't have a lot of development in this particular district. And then we have like major rivers like Vanganga, Indravati, Godavari joining here. This is Gadchiroli districts. We have Vanganga also. There's not much of exploitation. And when we did the study, the good point which had emerged from the study is the groundwater level in May also is very, very high. It ranges from 2 to 27 meters. So 6-7 meters. And if you go to Punjab, for that matter, even in Gujarat and Rajasthan also, we hardly strike at Tamil Nadu, we hardly strike water up to 300 meters or 400 meters. So this clearly indicates that if we properly manage our groundwater, it can even help in maintaining water quality. So groundwater development is 17%. This means that we only utilize 17% of water which gets recharged in Gadchiroli districts, which is very, very low. Whereas in states like Punjab, Rajasthan, Tamil Nadu, and Gujarat, development is even near 100%. That's why we have, say, groundwater depletion in this area. And the water quality, if you see, it's really good. We have TDS of 143 to 147.1. Whereas in places like Rajasthan, we are like 2000 mg per liter of TDS at 2500 mg per liter. Fluoride is also low, nitrate is also low in this area. So what I mean is that if we properly maintain quantity of water, we can definitely improve quality of water also. This I'll not spend much time. And I was talking about this. In this, what we actually did, these are the roof of the school, and we used the water in recharging these wells, and that had helped in bringing down fluoride concentration from 7.2 mg per liter to less than 1 mg per liter. This is my colleague, Dr. Paras Pujari, actually led this, and this also indicates that if we do in situ dilation, that helps in bringing down concentration of these pollutants. Okay, that's all. This is the last slide, and this is the book I have written along with my student Anshu Yadav. This is published by International Water Association. This is an open access book, and this talks about membrane-based point of view drinking water system. Those who are interested to know about household water treatment system should read this book. And this has 8 different chapters: water sources and quality parameters. We talked about water sources and quality, water supply system, and need for point of view water treatment system. What are different point of view water treatment systems? How should we design membrane-based point of view system? A student of mine, Anshul, has written this modeling membrane operations. how can we operate and maintain these membrane-based point of view water treatment system. We have done some techno-economic analysis also in 7th chapter, and how this system can be certified and implemented. So this can be downloaded. If you type this, I think you will easily get. So this is this open access means you don't have to pay anything for this particular book. That's all. Thank you very much. If there's any question from your side, you can ask. Otherwise, we'll hand over to Dr. Praveen Meshram and Dr. Vaishali Meshram. Thank you very much for your patience.
I would like to request that all the participants, if you would like to have some queries, you can directly ask one by one, please. Dr. Sheel.
Grey water treatment, sir.
Archana have asked some queries, sir. Dr. Archana.
Grey water, see, we have black water and grey water. So grey water is the water which comes out of our bathroom washing clothes. The black water is the water from the toilet. So it's much easier to treat grey water. So grey water, say, has BOD level of, say, 30, 40, 50 mg per liter as against 150 mg per liter in sewage. Similarly, COD is also as not as high, and more importantly, pathogens also are not very high. So we can use many techniques to treat grey water, and so we can use even this constructed wetland to treat grey water. There's something known as a vertical wall through which this can be treated. There's simple filtration system which can help us in treating grey water. So yeah, there are many ways we can treat grey water in which we don't have to remove organic to the extent which we have to do in our black water. So yeah, I have a full presentation on grey water, but yeah, that's all I'm about to say. In case if you have further query, I think you can be in touch with Dr. Meshram, and I can share some of the papers which we have done.
So thank you,
Otherwise,
sir.
Otherwise, we'll arrange your presentation next week also.
Sure.
Depending upon your availability.
One question, sir.
And the grey water. Okay, Dr. Suparna would like to ask.
Sir, my question is, do these RO machines, they really purifies the water and lowers the TDS, which generally are used in the households?
Yeah, yes. As I told you, this RO water can remove particles to the size of 0.0001 micron. So they can literally remove everything from water. But unfortunately, what happens is the essential elements like sometimes calcium and magnesium also are removed from this. So what normally they are doing is that they have bypass, something known as a bypass, and then a small stream from raw water is taken to the water which is treated from RO, and they say blend this particular stream to treated water after, say, UV disinfection. So they try to compensate for the losses of these TDS, which have been done through your membrane. So I think RO is good, but it's not good.
Yes, but no, generally, sir, doctor says that don't use the ROs. You are not getting the essential materials or what dissolved substances from that. That's why I asked that question.
Yeah, you are very correct. But nowadays, these manufacturers are very clever. As I told you, they try to compensate for the loss of TDS. And in places like Nagpur, I think we should not use wherever we are getting municipal water where TDS is already very low. So we are like 150 mg per liter.
Yes, they are always saying that use your normal water. No need to this.
Yes. You can like media filter followed by UV disinfection. That's good enough for places like Nagpur. So please don't go for RO in Nagpur for sure.
Okay, thank you, sir.
Sir, I have one question.
Yeah.
Sir, what are the xenobiotic compounds in that contaminated in water, and how we can remove that, sir?
I think, I don't know much about it, but what is happening? They are so small in size. dissolved fraction. Secondly, the concentration of these contaminants also very low in concentration. So RO appears to be only treatment right now, but in addition, there are some adsorbents which can selectively remove these xenobiotic compounds. So yeah, but what happens? First of all, the concentration is very low. At the same time, we really don't know, yeah, what are the different compounds there. In it, we might have to remove several other contaminants also from water. In that case, yeah, RO seems to be the only solution. But sometimes I feel that they are, say, overhyped. These contaminants are overhyped. Their health impact may not be as much as they are talked about. So I think we can still live with these xenobiotics unless it's in very large concentration.
Yeah. Thank you, sir.
Sir, please tell me the exact range of TDS. TDS.
Yeah. So we have like Indian standards, which is Indian standard 10500/2012. As per that standard, the limit of TDS is 500 mg per liter acceptable, and permissible limit is 2000 mg per liter in absence of any alternate source. So we can drink water up to 500 mg per liter TDS. But there is no lower limit given by Indian standard. Even WHO also is not stipulated any lower limit for TDS.
Okay, sir. Okay.
Any other participant? Anyway, just stop now. Huh? So, thank you so very much, sir, for your enlightening and resourceful session. I'm sure that all the participants must have got immensely benefited by your overall presentation on your divisional activities, then role of NEERI in environmental protection. Then you have also covered several case studies, then issues which are related with our water pollution with reference to our Nagpur city. We also covered various issues in all over India. The water pollution, their sources, causes, effects, control technique, various approaches to control the water pollution problems. Sir, I look forward for your cooperation once again. I may knock your door at for your next week also. I'm sure that you will say no to me. And so on behalf of Sevadal Mahila Mahavidyalaya and on behalf of Staff Academic College, I extend my sincere and heartfelt thanks for your accepting our invitation, sparing your valuable time for us, enlightening the participant with your informative presentation. Thank you so much, sir.
Thank you.
We'll be having. Now I declare
like
that
participants also. I would like to thank participants. They were very proactive. They asked thanks a lot.
All our participants are from environmental science, then life sciences and chemical sciences.
Yeah, very good. Very
good.
Thanks.
So now, sir, I declare that today's our inaugural ceremony, then first session, second session, they're all over. And thank you all once again. We all will meet after lunch at 2:30, where we have arranged the presentation of Dr. Farhat Qureshi, madam. Thank you very much, sir. Please.
Thanks.